Okay, so you just heard about how to use GPUs really well, very easily, right? And by the way, my name is Deok. I'm a product manager at CoreWeave. CoreWeave is a cloud provider. How many of y'all have heard of Sunk? Just so I know. Sunk. Okay, cool. I will speak to you as if you have not heard about it, so it's okay. You will learn more today. SkyPilot just needs to use GPUs. They give you a bunch of different ways in which you can run interactive jobs, you can run RL workloads, you can find the cheapest GPUs across cloud providers, right? Or whatever the best GPUs are for your workloads. I'm going to talk about the best GPUs for you to use with SkyPilot specifically. And then at the end, I'll show a new integration we're announcing today. We just pushed out a doc of how you could run SkyPilot on Sunk. And here he goes. So you're a researcher, you just you want to use your GPUs immediately. There's a checklist of things that infra folks at your company, or if you don't have them yourself, you're going to have to go through until you can actually run a production job. It goes from where are my things running, like the infrastructure underneath, if I have Kubernetes, or if it's just like a VM and I have to go off to the races myself. Where am I going to store my data? How am I going to pull my data? If I'm training a model, where do I keep the checkpoints? If I'm not training a model, I'm running inference. Like there's all of these infra things you have to set up. Once you have your infra, now you can optimize stuff. So your checklist keeps going. And then after you do all of these things, you can actually run the job. You can run inference. You can run RL, whatever the workload is, right? With Sunk, which is Slurm on Kubernetes, it's a proprietary product by CoreWeave, but it is built on two open source solutions. Slurm, which is a job scheduler. If you have a bunch of people in your company, you're all fighting to the death to see who gets the GPUs. Slurm is the thing that's going to allow you to fair share those resources. There's policies like, if my job starts in an hour and other people have smaller jobs, I'm going to try to run those before the big job starts, backfill scheduling. Or if I have a really large job that cannot be preempted, it needs to go and start and complete until it's done, I need to set a really high priority for that. So all of these are scheduling features that Slurm offers. We didn't create them, Slurm did. Now, if you're running at a very large scale, which most of our customers are, Microsoft, Meta, IBM, Mistral, Cohere, there's a fundamental issue of, I need to keep my things running well. I need to manage jobs across hundreds or thousands of nodes. I have a screenshot with 16,000 GPUs. I'm going to show you in a second from our customer. And if one of those GPUs fails, my whole job fails. And I'm spending hundreds of thousands of dollars per hour for, idle compute. And we can't have that happening. So we use Kubernetes to solve that problem. We have a bunch of customers. Does this work? Yeah. So over time, we've learned what breaks in the cluster, and we've fixed it for them. Every customer that comes into CoreWeave today, they get the benefit of our experience in seeing how things break because we've implemented solutions at the platform level through Kubernetes. So you get the scheduling features from Slurm, and you get the nice reliability stuff from Kubernetes. Sunk. Clear name, right? Very obvious name. Deploying Sunk is super easy. You can do so with like YAML file configure. If you're an infra person, you will be totally happy with Sunk. If you're not an infra person, we just announced this at GTC last week. You can click a couple buttons, you get a cluster up. Specify which Kubernetes cluster you want to use. So in this case, I'm selecting an existing Kubernetes cluster I have. I select which compute I'd like, B200s, H100s, just CPUs, whatever it is. And then I can specify who should have access to this cluster, much like you were seeing that SkyPilot screen with SSO and RBAC. This is similar to that. But basically, if you have an upstream provider like Okta or Microsoft Entra or Google Workspace, that is where your entities are defined. It will automatically put them to your Slurm cluster by default. So that's called Sunk user provisioning. It's quite a nice feature, actually. Anyways, once you have a cluster deployed, your researcher has this need to run stuff. All they need to do is they go to the console, they put their SSH key in there, they copy some IP for the node that they want to access. Then they can set up SkyPilot, or they can access the cluster directly, SSH to the cluster. Okay, so at this point, I have a cluster up. My researcher has a way of accessing that compute. Very easy, very secure. The alternative would be you have some YAML file with a bunch of people's emails and SSH keys. If someone leaves your company and you forget to update the file, guess what? They have access to your expensive GPUs. You don't want that. And then they can do their amazing ML, very smart thing of running jobs with Slurm. That's kind of what it looks like. Super easy, just a CLI. Not here to talk about Slurm. The next few slides is where CoreWeave truly shines, okay? If you're like a numbers person, the number you care about when it comes to reliability is if I launch a large job, think 1,000 GPUs, how often is that job getting interrupted because of some underlying issue with the cluster? You would want that number to be as high as possible. Ideally, your job never fails because of a hardware issue, right? Well, Meta actually published a paper about this, and their number was about 8 hours for 1,000 GPUs. And they know what they're doing, and they are improving it every day. We have someone here who will talk more things about observability and reliability. But the thing is, there's a million things that can go wrong at every layer of the stack. We have addressed them, and our number is around 70 to 80 hours for an equivalent job size, 1,000 GPUs. And so the observability starts with what can I get from the training side, the training code, if we break the code barrier. Like, I want to see crazy loss curves. I want to see some really detailed metrics about layers within my transformer model. Great. That's where you go to weights and biases. The setup is super easy. If you're using an existing framework like Megatron or Nemo, it's already built in, so you're going to get metrics by default. If you're doing something crazy, you can log really easily like so. So this is NanoChat by Karpathy. He has a loss metric BPB. And here I'm showing what you would see as your job is running, a bunch of panels with the data that you, researcher, want to see. Like, this is not news. It's been around for a while. You can create custom panels. So this is just a product description of weights and biases models, okay? So a lot of detail about your training code specifically, and you can go to town on what you want to log, actually. Now, this is where things start to get interesting. As in that example of I click go on my job, a couple hours later, I go to bed because my job is going to run overnight, and there's an issue. So CoreWeave will take action on hardware issues if we deem it to be possible. If you have a job that is still running after some hardware issue, but the performance is degraded, we will not take action because maybe you're fine with that for the rest of the night. But if your job stops, we will automatically replace that node and requeue your job. So you're sleeping, your job dies, we remove that node, and when you wake up, your job is running again because it got automatically requeued. So this integration with SUNK, which you have to set up according to our recommendations, allows you a shorter interruption time. And this is a view of what you would see if there is an issue. On the weights and biases console, we will surface hardware issues with a recommendation. For example, there is a CPU throttle error here, and I have the recommendation of CoreWeave immediately took this out of production and automatically put the node out of service. The job will be interrupted. In some cases, you may choose not to allow us to requeue your job automatically, and that's fine. Your job will just be canceled. And you can also see this when you're out for dinner. What a lovely companion that would be. Okay, and then just a couple more slides in observability. Who doesn't like to talk about observability and seeing all the data possible? So I got a lot of good feedback about this at GTC. We had a couple of customers tell us what they see on other cloud providers instead of like in terms of how deep the observability stack goes and what they see on CoreWeave. And obviously I'm a CoreWeave guy, so I'm going to be super biased on this talk. The point is we correlate job information that we get from Slurm with node information, with Kubernetes information, with cluster level information. All of these are correlated, so you can click around within. This is a job with 16,000 GPUs from one of our large customers. I can easily see alerts that are happening. I can go click on the nodes for which those alerts are taking place in. And if I go click that, I'm going to be completely overwhelmed, very high information density on a dashboard that we have pre-built. We have about 30 different dashboards that are pre-built, and it just works magically. It's managed Grafana out of the box for you. Just an example of the kind of data you can get. So GPU temperature, InfiniBand bandwidth, free RAM. This is actually pretty light, even though it seems like quite involved. In the other dashboards, we will have like entire sections dedicated to InfiniBand alone, dedicated to VRAM alone, dedicated to power consumption. You can slice and dice the data however you'd like. And with an MCP that we have now, you can totally like just have Claude Code figure out what's going on. The world is your oyster for that. This is the kind of contextual information that's helpful. If you're an infra person now, okay, we were researchers before, now we're infra hat on, okay? Researcher pings you in Slack, hey, my job has an issue. You can quickly access that through our dashboards. You click a button, you go to the job. You can see when there was a failure for the node specifically and the job, whether there was an interruption or not. In this case, it was interrupted here, but not here. Interesting. So in this case, the job stopped progressing, but it was still up. You know, those are things you can handle with training code, but as an infra person, you have to go figure out what to do and how to fix it. Yes, and there's an infinite amount of information. In this case, topology-aware scheduling is a very interesting topic. You get fancy GPUs from NVIDIA. There's a bunch of nodes in a single rack, and you want to make sure your job lands in a full rack if it's smaller than the number of nodes in that rack. The reason is there's some very fast networking connecting these nodes to each other. It's called NVLink. But if you have a job that spans multiple nodes and you do a poor job in scheduling those and they happen to land on different racks, you get a performance hit. So we give you that by default. We will schedule those jobs in the correct places based on the network topology, whether it's like a block system with big rack, a bunch of nodes inside, or your typical like leaf switch with a bunch of nodes in it. If I'm speaking Greek, it just means performance goes up, happy person, okay? And this graph tells the researcher what the most optimal settings for their job submission is. When you're submitting Slurm, you have to say how many nodes at a minimum each subpart of the job should have, segment size. All right? One more observability thing and I'll stop, I promise. Or else the pizza's gonna get cold, right? Yes. GPU straggler detection. So this is fault detection. I talked a lot about failures, like my job is running and then it breaks. There are two other kinds of issues. One is my job stays up, but it stops progressing completely. I just mentioned it. And then the third one is my job stays up, it keeps progressing, it keeps making steps, but at a degraded performance. So for each of those, the cause could be a bunch of stuff. We want to like check them off one by one to give you like an action. Okay, I know that this particular GPU is bad, so I'm going to tell CoreWeave it's okay for you to automatically remove this node or, you know, manually trigger that myself if I want full control. That's what we do with GPU straggler detection. We have a plugin, a nickel plugin that goes in your node. It has a bunch of information about how GPUs are talking to each other, and it's based on the iteration of something called a sequence number. Like it's talking to another GPU, and that GPU keeps talking, but this GPU stops talking to it. You can detect that this one is bad. It's either hung or it's just slow, and I pinpoint it exactly here. So in a 512 GPU job, GPU 511 is bad. And as the infra person, I have to go fix it or just tell CoreWeave, yes, like please replace this node for me. This is what the table would look like with more information on it. Here we artificially produced a bunch of hungs. You would never see this in real life. But I can quickly go to the node that is having the issue or the Slurm pod specifically. So this is a Kubernetes pod that is running Slurm. All right, so this is the last observability one. This is the data we produce with that plugin. There's an interesting story to be shared. I'm going to be brief about it. If you have one bad node in like in a group of 512 nodes, if you don't analogous to it that a bunch of other companies have built, you have to do binary search. So basically, you take a group with 256 nodes, you run a job there. Another 6 nodes, you run it here. Whichever one breaks, you continue to drill down further and further into that one. That takes time and effort, and it's expensive because you're not running your actual job. Sometimes you're running something called the nickel test to see, like, if I'm paying for all of this super fast NVIDIA, InfiniBand, the NVLink stuff, how much of it am I getting? You'd have to run a nickel test, which means you're not running your actual job. With this, you're running your job in production, and you are getting this data. So there's no trade-off. It's quite nice. And finally, we're done with the observability for now. Finally, we just launched this doc today of running SkyPilot on SUNK. So you already know how running on Slurm with SkyPilot works because you just saw a demo of it. This is just a doc about how to run it specifically on CoreWeave. There's no real significant change to it. Our Slurm is very similar to other people's Slurm. You can just follow the same steps. Install SkyPilot, easy enough. This is where you would put the IPs of the nodes you have access. If you have access to 10 clusters, you just set that in your Slurm config file. And now SkyPilot knows which clusters you have, what compute is in them. Great. So now I can actually run something. So you specify your task YAML. Here I'm saying the cloud is Slurm, my compute type, whatever it is, H100s, and then I specify what needs to be run in it. That's like the most simple thing. And then I launch it specifying that task YAML I just created. And then lastly, if you want an interactive development, basically if you want to run a notebook or give me the GPU just for myself, I want to play around with it, interactive workflow, very common. SkyPilot gets allocation of a node. It basically submits a job with an infinite end. The job will never end. And then you SSH into the node and you run whatever you'd like. It works the same on other cloud providers and other Slurm as well. This is no different than anywhere else. It just will run better on us. That's all I had for today. I think there's one more talk, right, following me. Scan that QR code for the docs and ask me any questions. I'll be to the side. Thank you very much.